And lucky for me, we get again to invite an expert to moderate the next discussion. And in fact, this panel is being hosted by the company CharIN, and it's being moderated by Claas Bracklo. So Claas, come over here. Give Claas a warm round of applause. And you guys are going to be talking about the Megawatt charging system. Event team, is everybody's chair and water sorted? It looks like they are. So now my job is done, and I hand over to you.
Okay, Mariana, thanks a lot, and thanks for your patience after lunchtime. And so I'm really happy to present in that moderated panel a group of specialists on Megawatt charging, and they are all involved in the Charging Interface Association I'm the chairman of, and I'm happy to give you a thought on different aspects. That is on technology, that is on vehicle, and that is on operation, on chargers, and finally on the CPO business. And I'm happy to have my colleagues coming on stage. So that is Vinzenz Stauner. He is with system development in MAN truck and bus. He gives us his insights view. And please sit down, Vincent. And we have Johan Peters. He's Vice President Business Development for ABB, a long-term CharIN member and sitting in our steering committee. And finally, we have Lars with EnBW. He's Vice President, Strategy and Sales. And we have a special guest, and he's hopefully on stage. Hi, Ted. Ted Bohn is currently somewhere at the dentist, and he is in the Argonne National Lab in North America and responsible for the research aspects on megawatt charging. And that is the subject of that discussion of today, having all aspects and to see the experts who worked in the background. And finally, we started our activity 3 years ago to power batteries which are bigger than 500, 600 kilowatt hours. That is 5 times more we are used to have in passenger cars, and that is the right time, which goes together with the current EU regulations set up. And so we are happy to present you the different aspects. We try to make it short and to give you the opportunity to ask whatever you like, because that is the opportunity today. You have all the broad band of inputs. I would like to start with a short presentation. So what CharIN is, that stands for Charging Interface Initiative. And so that is my entry slide to say, okay, what is our target? And we are all striving for a CO2-free society. And on the other hand, we have all these projections, and the current ones are going to 40 to 60 million electric passenger car vehicles in the European Union in the next 10 years. But that is the latest news from the Automobile Association in Germany. So we expect to have 20% of the new registration of heavy trucks in 2030 being electrified. And the rumor around is, so does it work? How it works? Is it a market? What is hydrogen? We say 20% will be electrical, and that's enough room to discuss about that. So the CharIN organization itself is a global one. We set it up 7 years ago from now. We have offices in the strategic automobile markets, and within those countries we have local representatives who are collecting the input from the local markets, and the head office is located in Berlin and headed, and so we try to manage that. Currently it's easy because it's virtual, more easy to travel around the world, and in principle we did more than we did before. And the growth rate you see is it's almost following the car development and charger development, but the number of members is not the number of quality. That is an impression. So who is in that organization that is acting globally? So we try to find a fair share between Asia, the Americas, and Europe, and we try to find an equal share between the industries, from energy to cars to technology. And what you can easily see is that we have a focus point in Europe. So that is not because I'm European, that is because the European market is one of the strongest and fastest growing markets in the world, with the most competition from industry, and it makes sense. And by evolving the market, so we expect to have a growing markets in Asia and Americas as well. I'm now coming to the MCS with all this potential and the members. So we are more than 230 now. So we have the opportunity to create technology with the combined knowledge from different areas of the world, from different industries. And so when we sat together 3 years ago, said, okay, what is happening if we are going electrical for these long-haul heavy trucks? And is there any technology available we can easily apply? We shortly thought about just putting a couple of those CCS connectors together, and from the customer perspective, that is bullshit, so you are not going to handle a different of those, so that has to be in one. The power demand is clear. The time restriction is a limiting factor, which directly goes to the power supply strategy. And at the end, the opportunity is in this surrounding of cross-industry memberships. We hope to create something which is then immediately adopted to the markets, and if the industry globally agrees, so we have some power against local government decisions and say, okay, if we make the pace, we will have it. That is an interesting slide. We started the activities in our North America colleagues arena, and we brought all people together who are defining the use case for transport. And that was not, so we are defining a megawatt system, it's more the other way around. So what is necessary to fulfill the use case of heavy duty transport? And as you can see, we have the utilities, but we have the customer and the fleet operators. And that took us, probably, I'm not quite sure, almost one year to figure out, so what is the technical demand to fulfill the customer need in that specific group. So we have 200-something people working actively and they are coming from more than 70 different companies. And as you probably know better than me, you need the complete value chain in technology, from a simple spring and a cooling system and the cable, and that is much, much more than just having a piece of plastic with a specific shape. That is one of the prerequisites. So we invested more than 10,000 man-years in the development of the CCS charging system, and the target was to incorporate as much as possible and take over from security and safety and experience and communication. Okay, the only difference is the bit higher power demand, and let's take the system as stable as possible. And as you see on the right side, that is the future design. And if the cloud is being a bit more clearer in time, so we expect to have that at end of this year. So we have the connector, we have the system approach, we make use of experiences from CCS, and that hopefully lead us to bring that into operation. All that stuff already went into standardization. Standardization takes us 2 or 3 years, and that means when the market readiness is required, we assume that is around 24. So we have technology and some quality rounds having done until that time, and that is just by fortune, so we started at the right time of point. That gives a short impression. So that is Rustam Kocher. He is the lead of that specific group within CharIN, and that shows a bit. It's feasible. It's not tiny, but it's not the big amount, so that truck charging is not handleable. And so that has been done in a national research lab in North America. So we join all the forces from the complete industry and research labs, and so we see to have that finalist, there is no hindering block visible, and so we assume we did our best in preparation. And I would like to hand over to Ted, who is one of the early members in that CharIN task force having set up, and he's giving us his impression and thoughts about perspective of megawatt charging. So Ted, I hope that works. I try to move the slides. Welcome.
Can you go back to the intro slide on the 1930s truck?
Okay, that's your.
Yeah.
Okay, Ted.
So anyway, you can see what
your
I can
stage.
see. Thank you. My name's Ted Bohn from Argonne National Lab. I'm in a waiting room at a hospital right now, so I don't think I have to wear a mask because there's no one else here, but later on I'll put my mask back on just so you understand why I'm wearing a mask as a presenter. So you have to put my slides up so I can see them. I only see myself. There you go. Thank you. So this slide, and again, at Argonne National Lab, we do a lot of fundamental research on interoperability, and I do a lot on basically where we were, where we are, and where we're going. And again, a lot of the testing on functional and interoperability is, Argonne is an independent third party, so we don't have a stake in the game, so we can just state things as facts. So in the image you see there is the 1930s, there's a UPS fleet of delivery trucks using DC distribution in their facility, where we were, where we are. Next slide, please. So as you see in the upcoming slides, the plaza itself on how we get everything from the utility interconnection on the upper right with local generation, storage, and distribution up the middle on the bullet mark 3, where you have the distribution to the different vehicles, to the kiosks, which is at 4, to the vehicle side on the inlet, which is 5. So again, these are all the pieces that lead up to how we have a megawatt from the grid to the vehicle with cooling, communication, safety. Next slide. The other thing is we have a lot of crossover applications that are going to use the same couplers. So you can see in the upper left the eVTOL and a lot of investments both in Europe and the United States. The image in the center is an example of what not to do. So there's a ferry in Bangkok that uses 26 CCS inlets to charge the ferry. So again, this could be achieved at higher power, higher current, and higher voltage with one connector. Up on the right, you can see the construction equipment. Again, a lot of these things would like to use the same plug and the same power levels. In the lower row on the left, you can see mining equipment is a very big thing to untether. So this one shows an electric mining equipment that has a cord. They would like to cut the cord. In the center is in south of France on the yachts. And then, of course, yachts will like to have electric yachts because they're clean and quiet and don't need a generator when they're idling. And then, of course, ag equipment. Next.
Oh, sorry.
Oh.
There you go.
Did we skip a slide? Can you go back? I guess that was it. So it's a very short deck. So going to the next one, as a segue, here is an example of what not to do. Lots of connectors. We can see from this example how communication would be an issue on noise and other issues plugging in so many different things. And again, the whole coexistence interoperability. So that's the part that I'm working on. And so communication reliability is very important, and I'll hand it off to my next speaker.
Thank you very much. Yeah. Let me quickly introduce myself. My name is Vinzenz Stauner, and as a system developer, I'm responsible for the vehicle internal charging system of electrical trucks and buses at MAN. We are an OEM for commercial vehicles located in Munich, Germany. And I would like to introduce today the crucial topic for the success of megawatt charging, that is also a reliable and flexible charging communication. Because reliable is especially important for the commercial vehicle application, because if the vehicle cannot charge, the vehicle can also not drive, and if the vehicle cannot drive, the user loses a lot of money, of course. And flexibility is also important given the higher charging powers that we have for megawatt charging. So that makes, for example, a grid integration and also the intelligent charging process planning even more important than we have for the lower charging powers today. For megawatt charging, we evaluated, or we see 3 main risks for the charging communication. That is the longer charging cables, because we have also other use cases coming from aviation or marine industries. We also have, of course, much higher charging powers, so roughly 10 times that we have today for CCS. And also due to advancements of power electronics, for example, we will have higher switching frequencies. And these all reasons increases the noise level or makes it from noise much easier to couple into. So, and these risks we would like to evaluate in the MCS task force, and therefore we founded a subgroup back last year where we are roughly 20 active experts. That's called communication subgroup. And our task is first to check if our today's communication system based on single-ended PLC is stable enough for megawatt charging, and also discuss possible alternative physical layers that makes the communication more robust. But we also have clear premises. One important premise for us is, since we want to take over the ISO 15118 communication protocol and its ecosystems and benefits, TCP/IP support is crucial for us. And also, since we are coming from the CCS ecosystems, we would like to change as few requirements as possible. but of course also allow a place for lessons learned, and so that our system will be really robust and the best possible system. That's always our target. Yeah, but what is the PHY actually all about, or the physical layer? I try to explain you with the picture here that you see on the right. Imagine that you have a gorge and you have some vehicles that want to cross the gorge, but in the gorge there are some dangers like those nasty EMI crocodiles that just want to disturb the communication, so to say. And that the vehicles can pass the gorge in a safe way. You can just build a good and stable and also a wide bridge. But if the bridge collapses, that means if the physical layer collapses, then my data packets are lost and the communication and the charging aborts, and that is of course not what we want. On the left you see the communication stack model from the ISO 15118, so from physical layer up to application layer. All those layers needs to be implemented, but we are just looking in the subgroup at these bottom two layers that are today implemented by single-ended PLC. And we check are these two layers stable enough, and also discuss alternatives, but the alternatives has to fit in this layer model, because we don't want to change the upper layer, so we just look at the two. But how we do that? We conduct noise immunity tests, and also we collect noises, real noises from charging systems from the field. So TED, for example, at Argonne National Laboratory records noises from real charging systems. Also at the University of Zwickau, we have PHY tests or physical layer tests now conducted. And we also evaluate possible alternatives in case it turns out that single-ended PLC does not have the noise immunity that we need. They are then all differential. So, for example, you can also have a differential PLC communication that is then robust. And yeah, we want to finalize these discussions and decide the physical layer until end of this year. Yeah, thank you. I hope I could give you a good introduction. I'm looking forward to the discussions later with you. But now I would like to hand over to Johan, who will tell you more about grid and grid integration. Thank you.
So, thank you very much. So the good news is there is a standard coming for MCS. We are close, thanks to CharIN. ABB is active member, and we are working very closely together in the CharIN committee to get that standard out. We are a strong believer of standards. So let me go back about the early days of eMobility. So, okay, the early days of eMobility, 2009, we started with, or at least our company started with eMobility. And in 2009, 2010, the discussion was, we're going to charge a car with 50 kilowatt. And that was unbelievable. That could not be done. The batteries would explode, the grid would collapse. I mean, impossible. That was also my first, this is huge. This is massive. Look where we are right now. We're talking 1 megawatt, 2 megawatt, 3 megawatt. We're talking airplanes. So I want to quickly run you through what this would mean and how you would use these systems and what use cases are and what this means for the grid. Okay, first of all, it's not about do we want to charge faster? Do we want to do a megawatt charger on a car? That's not the idea. The idea is that you adapt your charging speed to the use case, and I will show you some examples. For instance, you can have a depot where you charge overnight, or you can have on-road where you want to charge quickly. So all these different use cases have different charging needs, and MCS is fitting in certain applications. So what we see today, we have today in Europe, also in USA, we have CCS2 up to 350 kilowatt. And what we see today is that these chargers are actively used today by the first electric trucks, intercity traffic, and this charging power will fit the need for intercity. So 350 kilowatt is doing a pretty damn good job for this application already. And that is there. The technology is there, it's working. We have the right power. So that's what we see today. So this is an example of Ionity. And for instance, the bus will drive back. I just learned from here. So the MAN bus will drive back to München, and they will use the public infrastructure. So, okay, that will be a good example. Of course, if you have long route of long distances, then it doesn't work as explained by Claas. and we need higher power. So the nice thing is that's defined. The connector is close to defined. We're talking 1 megawatt to 3 megawatt. So what we're building is we have the existing systems, CCS2, which can do the job for intercity. When the vehicles are coming, the trucks or planes, you name it, we move to this 3 megawatt level. And the first systems, as ABB, we will have first pilots running next year with MCS. And then in 2020, end of 2022, we are going to levels of 2 or 3 megawatts, which is in line with when the cars are coming. Now, what does that mean for the grid? 1 megawatt, 3 megawatt. Also, it's not one charger. It can be many chargers. It can be maybe 10 chargers or 20 chargers. So what does it mean for the grid? Now, if you would simply apply these chargers, put them on the grid, then you definitely have an issue. And the issue is not the high voltage part, but I would call it the last mile. So how do you deal with the last mile? Now, luckily, there are solutions for that. So if you do the on-site, if you clever manage the energy, how you do that? Vehicles are maybe not coming at the same time. Maybe you can do some peak shaving, add some batteries. Then you can limit let's say, the disturbance on the grid. So my message here is that the grid will not be the bottleneck. Of course, you have to do stuff, but it's all very well manageable to do it. So the grid will not be the breaking the whole case here. Quickly, what's happening between, let's say, the last 10 years and where we are moving to? This is not only applicable to MCS, but in general. So initially, at the early days, let's say 2010, we had just a charger, and we put a second charger. There was no control. It was just what the charger needed, and the whole thing was, is the damn thing compatible with the vehicle? That was what I call charging 1.0. That's 10 years ago. Very quickly, we found out maybe the grid is a limitation, but by clever managing the energy, or let's say load management, without having too much implications, you can get more out of your existing grid connection. So you intelligently control the power. And where we are today, I call it 3.0. So if you add then energy storage, then you can do peak shaving. So you don't have to upgrade with energy storage unit, with load management. You can get already a long way. And the future, I would say this is where we have quite some experiments. The whole idea of vehicle to grid will come, and aggregation, but we will see that happen mainly in the AC space. So I believe that for megawatt charging, probably vehicle to grid, I don't think technology can do it, but I don't think that will be a main use case. Okay, so this is like we had a charger 10 years ago, just 250 kilowatts chargers on the grid, nothing there, just straight on the grid, 100 kilowatt connection. This is where we're moving. And in the conference the last few days, yesterday and today, I mean, this was mentioned already a few times. You first have your cars, and you have many of them. Can be maybe 10 or 20 trucks which all need 1 megawatt, yeah, or even more. And then you have these flexible loads, wind, solar, yeah, so which is coming in at maybe you can predict. You can add energy storage to it. So the first step would be don't blow the fuse. Energy or load management, that's the first step by a local controller. The next thing is you can add energy storage to it, also locally controlled. And then if you add the next layer on top of it, you can start to do site energy optimization. And that we do with the virtual power plant. So these local controllers can connect to the chargers, to the assets on site. And with the virtual power plant, you can optimize, you can do aggregation, and you can do clever energy management. When energy is cheap, you charge maybe faster and so on. So this is kind of the bigger picture, and everybody's moving in that direction. So this is, I would say, charging as of next year. Now, how does that look like? So this is our vision about specifically e-truck charging. It can also be, we are working for airplanes. We're doing charging for airplanes. That's coming as well, also in the range of 1 to 2 megawatt. What you see here is kind of an MCS charging system. It's a mix. So what you see on top would be, I have to do a long distance. Let's say I need to drive to München or Italy. I need to make one stop. You stop for 45 minutes. That will be typically a truck stop, and that's between 1.5 to 3 megawatt. The first implementation will be 1.5 megawatt. If, however, you have time, or overnight, so I have 8 hours, then you will not charge with MCS, then you charge it with existing CCS. And we believe, and also in discussion with truck makers, the trucks will have 2 inputs, MCS for the first case, but if you can charge slower, then you use the CCS. And there are even lower powers with standalone chargers. So our vision of the future is this mix of different systems, and you apply the power where it's needed. If you don't need to charge very fast, then you use the other ones. So this is a little bit our vision of what will happen, and the message is the grid will not be the limiting factor, so there are clever solutions to cope with that. Thank you very much.
So it's good to hear that the grid won't be the issue. Well, it's the first time actually that I'm speaking about megawatt chargers in public. As you know us from ramping up the biggest DC and high power charging infrastructure in Germany for cars. That's where we come from. You've done my story. Sorry.
Apologies.
No problem about that. 5 years ago, we started with the first DC chargers, actually, and 4 years ago they were ABB, actually triple chargers. Then we ramped up the first bigger hubs, and now we do hubs like the last one in Unterhaching with 20 high power chargers, which is not 20 megawatt, but it's 2 or 3 megawatts, like these kind of sites. And there the grid isn't the problem. But it just shows how fast this development went in the last few years. And another 5 years ago, there weren't any cars to be able to do DC charging. It's really rough, very, very, very hard and fast developing market here. And it's all about sites. Currently, we have 600 locations in operation, another 100 in construction, under construction. And it's hard to find the right sites, right locations, and it's even more hard to find the right locations or to develop these locations, these sites for megawatt charging, because the requirements for the locations are even higher as the trucks are bigger. Actually, they need a lot of space. Charging needs to be there where the vehicles are. It's like in the car as well. You can't force people to drive there or there, because only there you can charge. You have to try to follow their needs and make it rather easy to enter this infrastructure. You talked a lot about the grid. It has to be grid centered. It has to be there where the grid is, and the grid has to be there where the sites are. That's a challenge. It won't be the problem, actually. It's always possible from a technological point of view. It's always possible to solve these issues, but it's a question then about, of course, also about business case, business model, which leads to it has to be operation centric. So it has to be there where the space really can be provided, and it's easy to understand that along the motorways, this is where the petrol or the service stations are, or where the car parks are. But there is already some sort of infrastructure for cars, and it has not been designed to charge trucks there as well. It's an additional development that has to be taken under control, and has to be started right now, because right now there are targets defined, actually, to be able to provide this solution for mass market e-trucks. There has to be an enabling backbone from our perspective, and this needs to be in place actually before the cars can be sold, or the vehicles, the trucks can be sold. Otherwise, the bigger transport companies won't use these cars. They need to be operatable, and there are clear targets defined. You already mentioned Fit for 55 program. That's a challenge. Actually, there are political targets, but there is no really business plan yet to ramp that up. So we need to have this common target. We have to define and work together in this challenge to enable this backbone to be in place in the next 4 to 5 years. Otherwise, I think this wouldn't be possible. And one example to do that is the HOLA project, as it is called in the shortcut Hochleistungsladen im LKW-Fernverkehr. And within this project, one of the initiators sitting here, we will be able to build the first corridor from Berlin down to Nordrhein-Westfalen with 4 MCS locations, with 16 partners involved, with real trucks from Daimler, from Traton Group, from Volvo, providing these heavy-duty trucks, with us being able to provide to operate these charging sites. I'm quite sure this will be some sort of, you can say, the SLAM project for e-trucks. The SLAM project 5-6 years ago was some sort of the mother of the DC projects here in Germany, and maybe this could be the mother of the MCS projects here in Germany as well. Welcome.
Okay, Lars, thanks so far, and thanks for being in time, because I announced to have some room for discussions and your questions. So you have the choice to ask, so you can have or address specific issues to Ted for probably North America stuff, and we have the car side, the energy supply, and at the end the operations. And so I hope you are having some questions. If not, I have hundreds in addition to that we showed. So I'm waiting for impressions. If not, what is the challenge, Johan, from the charger side? So what is the difference if you're going from a passenger charger to that? So that is it building blocks, or is it the amperage or the voltage, or what is the risk or the challenge to do that, or is it just the shape of the connector?
Well, power electronics that's done before, right? So if it's now 50 kilowatt or 100 or 1 megawatt, we have done that many, many times. Of course, you have to bring it in the right packet. So I don't think power electronics is the issue. The main thing right now is the availability, I would say. So we have 1 megawatt systems. That's not a problem. Of course, we don't have the connectors yet. So the connectors are kind of almost ready, but they're not yet there. So the biggest thing for us to implement would be available connectors and cables. I think that's the #1 requirement. Of course, on the protocol, the nice thing is that we're using CCS, so that's very well known. Robustness there has to be improved of the power level, so there is this discussion about differential PLC. So I would say that's, long story short, the cable and the connector availability, and of course the trucks. The availability of the trucks, who can take the power. But we will provide the power, whatever is needed. But I don't think a charger is the issue in the rollout of this.
Okay, yeah, thanks so far. And it goes directly to Ted. So you are involved in all these measurements at NRLL, and so what's about the connectors? So what is the missing piece? Is it just to melting some plastic, or what is with the amperage, or is it just to making a thumb-thick connector pin? And so what is the challenge from that side, and what is the current status? And is it?
I'll back up and say that everybody likes measure twice, cut once, and so before you release something production, you need to make sure that it's tested and tested to full cycle life. And so there's been 2 rounds of testing hosted by my colleague lab at NREL in Colorado on 2 different revisions of the design on both tooled parts and 3D printed parts. And so the insertion force is an important part of the design, such that the materials that are used for the connector don't increase in insertion force with fretting and wear on the connector, because you still want to be able to plug in the connector at the end of life as you do in the beginning of life. And the same opposite on the contact resistance, that every micro ohm is a watt. And so you can see how at 3,000 amps, I squared R is going to be a really big point on getting the heat out. So change on contact resistance is going to be really important. So anyway, that's the gist of what's going on in the United States is the whole testing, both insertion force, wear and tear, materials, and then of course we've had to go through 3 iterations of the connector because of design decisions that made us change the path. We think by the end of December, the final design will be locked in, and that it can be made public by spring. So that's kind of a rundown of where we are and where we're going.
Okay, thanks so far. So first question is dropping in: is MCS infrastructure comparable to hydrogen, and what is the cost comparison on that? Does anybody have thought on that?
On the charging, it will definitely way cheaper than a hydrogen pump station. So infrastructure itself is, yeah, of course you need the grid, but the implementation is way simpler. I'm not an expert in hydrogen, but from a safety point of view, storage point of view, implementation point of view, I think it's much more complicated, and I think it's much more expensive. That's what I believe. From the usage, okay, I still believe that electricity, if you can pump it directly through a charger into a car, the whole discussion about efficiency of hydrogen, if you take electricity, green electricity, you make hydrogen, you transport it, and then you burn it in a fuel cell to make the electricity, I mean, the loss is 60%. So I personally believe that in the end, from a cost point of view, electric trucks will be way cheaper than hydrogen in usage and also in infrastructure. That's my opinion.
I agree.
But maybe MAN has a
Yeah, I
different
agree.
opinion, I don't know.
So no, I agree with you. So the well-to-wheel, the whole process has to be considered, and also in the vehicle you have to, as you mentioned, the storage problems. You have really high pressures that you have to deal with. Safety, hydrogen is very explosive and in a certain mix, and yeah.
The very nice question is dropping in: is Tesla involved in the CharIN discussions with the Tesla Semi? And so, as I mentioned before, we collected the complete industry in that specific group. We call that the MCS task force, and they are all who are in business for heavy truck transport. That is Nikola, that is Tesla, that is MAN, the Germans, Europeans. So that is really the approach of having a worldwide stuff. And what we all learned on standards, and it makes sense to have a common understanding on charging and technology, and that includes Tesla and all the others. And that is good to share experience, to bring in their thoughts, so they are quick in development, the others are more experienced in the rollout. But there was never having any thought on that, doing individual things on truck, and it would hurt dramatically the industry, and so nobody has any patience to do it specific, and the volume is not as high as in passenger cars. And yeah, I recognize a lot of fruitful inputs from the Tesla colleagues, so that is giving fruitful information, and the combination is it, and the combination from different use case from different areas of the world. So that could be another explanation probably. So what is the difference in the world from truck transport and charging demand? Probably you, Vincent, have some thoughts on that?
Yeah, so we have, for example, you have different weight classes. You have also different legislatory requirements. For example, on how is the vehicle used. In the US, you have normally shorter driving breaks that you have to take into account. So you have also different charging durations, and this is basically so the difference that we have to deal with. Yeah. Also, for example, in Latin America or in Asia, the vehicles are can also be normally lighter and does not cost so much. And this is the aspects you have to cover everything. Yeah.
Okay, thanks so far. That is a nice question again. What use case do you see besides the heavy-duty truck application of MCS? We showed some pictures. Johan mentioned some things. So if Ted is in the line, Ted, what is your plan? So are you?
This is a fantastic question, because the European Aircraft Association and again they're trying to harmonize globally. So within the SAE aircraft side, the AE7D committee and the SAE 6869 is already planning a high power connector, and they're evaluating different methods, and again, looking if the ISO 15118 communication protocol is acceptable, and if everybody accepts it, we can unify on one connector with one communication standard, and as Vinzenz knows, with a physical layer that's compatible with all the different industries of mining, aircraft. But I think the eVTOL electrified aircraft need fast turnaround. So while they're unloading and reloading passengers, the same with the ferries, but they already have an automated connection system because they have a dedicated dock for bringing the cars and people on and off. So it's a little bit less of a question on variability. But aircraft don't always pull up in the same spot. And of course, eVTOL aircraft land on the X on the roof or in the parking lot or wherever it is. So there'll be a lot of very interesting, aggressive ones. And then, of course, like I said, for mining, marine, as in pleasure craft, right? So there'll be a pleasure craft market that's going to basically say, if I can get a 1,200 horsepower, internal combustion engine, what if I can have a 2,000 or 3,000 horsepower electric drive that basically lets me cruise, with no emissions and no backup generator. So those are the premium markets that are going to basically drive some of these to be, simple, safe, and of course, economies of scale. I think the last part, economies of scale, is the most important part. When you see that the marine and people want to have something with 10,000 cycles, can, drive over it, drop it in a bucket, all the different safety features that are built into the MCS, and, have these automated connection systems is another going to be a big part of this, that the camera can see the vehicle inlet and can insert and extract the connector without a human involved. That's a big part of this. So those industries that can take advantage of automated connection systems with an interoperable and somewhat universal connector, those are the markets that are going to develop earlier. And again, trucks, buses, other medium-duty delivery vehicles, they're going to certainly move as fast as they can, as we see with the pilot fleets that have been announced, like in California at Frito-Lay and some of the Tesla fleets. They're going to have betas in the field by the end of the year.
Okay. May I add one aspect? So for example, coaches, it's also very, very interesting use case, because you don't have the 45 minutes, you have only a couple of minutes, because you have normally 2 drivers. And so this is also one aspect that sometimes it's forgotten a little in the discussions. Of course, it's a second step, but this will also be challenging. There I think we have to use up to 3,000 amps then at the end. Yeah.
That would lead me to Lars. So Lars, you are one of the market leaders in passenger car recharging. And so what happens? So are you going to harbors and supporting airports? And so you are in strategy and sales. So that seems to be a great opportunity to step in.
It seems to be the next big thing, I would say. But actually we are really very much focused on doing what we're currently doing on developing this high-power charging grid. But the most important question now is really, what's the requirement for charging infrastructure until which point of time? And I'm quite sure if that's more visible, like having roadmaps more transparent, how many trucks will be on the road in which year. It's not like hand and egg. I don't want to stress something like that, but it's like then it's more clear what's the requirement in terms of amount of infrastructure, size of infrastructure, grid requirements, and capex actually, and funding and things like that. So we're talking about there's a need for some sort of business plan actually.
Yeah. Okay, thanks so far. The next is fuel cell versus MCS. So what will the market share look like in 15, 20 years? And that is an interesting question. So we had a debate for 10 years on that, but we forget to start activities. And so, as we mentioned, we started 3 years ago. We have the HOLA project with the market Stärker. We are coming to market. We are making our experience. We have this great supplier base with a passenger car experience. And so that is a making group. And whatever happens, I think the maker will make the game. And as I stated, that is the German Automobile Association calculation to have a 20-30% market share at least for electromobility. And so currently we avoid to have this dispute because that does not help. In any case, we will have a fair market share, and the share of electricity is as high enough as it makes sense to invest in. And Vinzenz can probably say something during the timeline, which is first, and future strategies on that.
Mm-hmm. Yeah. So in general, the market will decide as you see, as you said. So in the first year, so the BEV electric vehicles, they are robust. They are in use. We have a lot of build up a lot of knowledge on that. So in the first years, we will definitely have a vast majority BEV electric vehicles. MN is doing also research in fuel cell vehicles, but I think that will take some more time to get the problems that we've mentioned earlier solved. And so this is why I think maybe in 20 years we will not have so much fuel cell market share. We will have the ramp up of the BEV electric trucks, of the coaches and of other vehicles, and then maybe we have a smaller market share for fuel cells at this time. But
okay, thanks so far. But that is the speculation. The other is the operation. So I would ask Lars. So what is your wish to all of us, to the truck builders, to the charger suppliers, to the technology aspects, and so what do they need to do to support your future strategy on ship, boat, harbor, bus, and truck charging?
Yeah, I would say it's really join forces in terms of open your mind and open your books somehow, and open your let's do some sort of exchange on what's really your plan and what's your plan on the roadmap, because then we don't get any hen and egg chicken and egg issue. We just get a common plan. We need a common plan.
Okay, and Johan, your position on customer use case, and so I try to address it a bit to say, okay, we are not making technology by technology's sake, and so what is your perspective? The new customers, new fields, so who is determining what the technology path is going?
What we see is that you will see announcement, again, there are things which we couldn't imagine 10 years ago. Electric planes, even if you say it right now, people don't believe it. There will be an announcement from ABB next month, where we announce the first partnership for electric flight. So those things are happening, and you see that what they want is, again, give me a standard. We have learned it. Also, Tesla, I think Tesla did fantastic things, but also in the end, Tesla moved to CCS because you need to join forces, as you said. And I think the good news on MCS. We specified MCS, we said it's 1.5 to 3 megawatt. Now we hear already maybe, is it enough? But at least there is room. And I think what we have learned from ABB and what we have seen in eMobility, standardization is so damn important. And the cooperation between car makers, utilities, we really have to work together. It's not, we cannot do it alone. So that's what I've learned. And also Tesla now, which was seen as a proprietary, they are now part of the game. So that's the only way to do it.
Okay, they follow with the next question.
I see a question here. So what is indeed the minimum required grid connection? So I showed you that the charging power is always linked to the use case. So it doesn't make sense that, let's say you have an MCS capable truck and the truck is standing somewhere for 6 hours, you will not charge it with MCS, you charge it with CCS. But when do we classify a system as MCS? When it's somewhere around 1 megawatt, 1.5 megawatt. Now, in that case, if you have one charger, then I would say the minimum grid connection to make use of MCS, I would say 1 megawatt is really the minimum. What we see in reality in the future, as I shown in the slides, is that you have maybe 10 outlets of 1 megawatt or 1.5 megawatt. But of course, if you add them together, you don't have to have a grid connection of, let's say, if you have 6 connections, 6 times 1.5 is 10 megawatt. No, because charging is tampering after a while. So there is what's called a utilization factor. Trucks are not coming at the same time. And I would say minimum 1 megawatt. In reality, in the future, we will see this will be connections of 10 megawatts, maybe charging 20 trucks, up to 20 megawatts. But I would say between 1 and 20. To give a number.
So next question is directly going to your direction, Peter, Johan as well. What is CAPEX on an MCS?
Yeah, so I can give you a price, of course, but the good news is good news and bad news. But I would say good news is it's a standard. Let's look what's happening in the segment of 50 kilowatts. Initially, there were only a few players. Pricing was high. Now there are many players. And competition drives it to let's say, today you can buy a system at I would say, reasonable cost. Exactly the same will happen at MCS. Initially, of course, it will be more expensive, but at a certain moment you go to levels which are, I would even say, if you take a charger today, to give you a number, 150 kilowatt or 350 kilowatt, I would even say, make it kind of linear, and you have a number. Yeah, of course, the connector will be so it's not that it's 3 times more expensive per kilowatt. I mean, it will be similar, so that you can do your own math on that one. So it will not be that expensive in the bigger scheme of things. So.
And this said, I'll jump in with that assessment that on the per watt, it will start at the same, and with economy of scale, it will certainly go down on per watt.
Yeah.
And the power electronics can be identical. And the other thing I was going to say, when you talked about the hydrogen versus electricity, there's also upgradability of the CCS to MCS is mainly a mechanical change, not a communication stack or minor changes on physical layer. So you could have upgradability of the existing systems to the new systems where you can repurpose old systems. And as Johan was saying, you're going to have this utilization factor where you can have shared stations. And so reconfigurability is also a big part of MCS. And of course, the evolving infrastructure is the whole on bidding a project. You don't bid it as one charger per site. You bid it as banks of chargers per site.
Yeah, we have one question you can answer, Ted. So what is the role of load and energy management? So as we stick on all the features of passenger cars, so we have the opportunity. Is there any specifics in truck and megawatt charging on that issue?
So that's a lot of what I work on within Department of Energy and other funded programs, that we have a grid-friendly and grid reactive, and again, in the United States, there's something called FERC order, the Energy Reliability Council requires that everybody be able to participate in the energy services market. So there will be people who are selling the change in load. So again, not the magnitude of load, but the change in load. And so that's actually going to be a revenue stream for a lot of places. And so when you talk about the utility management, that's not really even a negative side of having high load. The ability to adjust it up and down is going to be a revenue stream. But the active load management, there are standards coming. So IEEE P2030.13.13 is a standard that focuses specifically on that, on using the vehicle charging as part of a DER or a DERMS installation, and so it's not, like I said, it's not a bug, it's a feature. This load is actually something you can sell, the control of it.
Okay, thanks. And so that seems to be one of the later questions. So that is going to Lars, I assume. So if we have different charging needs and limited places, how will we distribute and prioritize the vehicles working at the point of charge? So you are one of those CPOs, you know the issues in passenger car designs, and now different demands, different sizes, different cycles, pricing, space. Any idea on that, or do we have experience by
difficult question
by real life experience?
Well, actually, we really believe that for the time being and for the next years, it will be really crucial to offer redundancy, to offer as much charge points as possible. But later on, obviously, there might be necessity to prioritize, to distribute, to manage the limited places. But actually, we don't have any experience yet how this could work in commercial vehicles.
Do you see reservation needs, or is it
probably
drop in and being lucky
necessary,
or not?
Probably necessary, and also do some sort of routing towards the best available from different perspective, best available charge point then.
Johan?
I like to add something. In the end, it's all about economics. We can dream about the climate, but in the end, it's about pure hard cash. I mean, that's the way we operate, seems to be. And if you look today to, if I charge my electric vehicle, I charge it at my home or at work, because that's the cheapest. And I only charge it the long haul if I really need to. And I think I expect the same will happen for trucks, is that if you want to charge at 1 megawatt, I expect that the truck driver comes in, and if he drives to the 1 megawatt and it can be automated, he probably will pay more for if you charge at that speed than if you would go to a 150 kilowatt station. That's like today we have AC, lower cost. That's what I expect will happen, because you don't want, you want to optimize your. That's what I think will happen. Yeah. And they can be automated, but let's see.
Okay, yeah, in a summary it means, so I have a very good impression. It seems to have the right people around, so thanks to Ted for all your support, and so I think that is quite important to have the research part quite well done and have some governmental support on that, and that is a perfect glue of industry and government, and that on a worldwide scale, and I think we can benefit out of that. So thanks to your activities, so Vincent, so I hope we will have that done, and so we have some things to do on robustness. And Johan, you gave us some figures, and I captured them. So that is double power means at maximum double money. Probably there is some potential, and Lars is going to make that at the customer interface, so to everybody confidence. And I would like to thank you for having their questions done and for your patience. And as you see, if you have never thought about megawatt charging, that could be one of the subjects of the 1 or 2 years perspective of the ICNC conferences the next years. And I have officially stated that is the formal end of this plenary session stuff. I should care for emptying the room because the next workshop is coming in, and so we have been the last presenters in the conference format, and thanks for activities and questions. And so I'm sure we come back, and probably at that site we will have an aviation electrical landing space for the next time, where our colleagues from the charging industry can supply the energy to that flying objects. Ted, all the best for your doctor issues, and hope it went well.
Yeah, like I said, I'm just waiting. Everything worked out fine. I'm signing things and whatever I was supposed to do, so I was able to dovetail. And that prediction, it's always fun to say. Think last year when I said next year we're going to have an eVTOL in the parking lot. Could be. I would say over 50% likelihood.
Thank you. Bye. Thank you.
Thank you.